Hello Linux lovers, my name's Wimpy, welcome to my world. How are you all doing today? If you're watching this after the fact on YouTube, this was originally streamed live on twitch.tv/Wimpy's World. I stream every Monday, Wednesday and Friday, so if you want to join in interactively and live with the rest of the community, then give us a follow on twitch.tv/Wimpy's World. Today we're going to be looking at Retro Home, my OS for retro gaming on the Raspberry Pi. And we're going to be optimizing that so it's suitable for not just the sort of set-top box style cases, but also a mode of operation which is better adapted for handheld devices. So this is going to be focused on how to minimize the image and remove some things that we don't need. And I'm going to go through how we're going to achieve all of that. Good morning. Hello, Paul. How are you doing? So I'm going to go over a few things. If you were here last Friday, it all went horribly wrong in the build system. I figured out what went wrong there. It wasn't a bug as such, but we'll dig into that. We'll look at, I've made some improvements to the drivers that we created on Friday, so we'll look at those, why I've made those changes. Then we'll look at the optimizations for how we're going to run this thing on a handheld device. And then what we'll do is we'll rebuild the image and test it on the dev machine here with those optimized changes. So that's sort of what we're going to be looking at today. Hello, it's only a gnome. Welcome back, Diego. How you doing? Hello, Takov. Takov is working on a branch here, and he's working on a whole bunch of GPIO driver stuff. So I'm doing the bit ahead of Takov's more interesting work, which is before. So for example, this is the sort of device that we're looking at here. So this is a GPI case. This is the version 2. And the way that this one works is you put a compute module 4 in the back here, and this is a Raspberry Pi powered handheld device, which is in exactly the same form factor as the original Game Boy. So this is just one example of the sort of handheld devices that I want to get this thing working on. I have 2 or 3 other handheld cases that use different types of Raspberry Pi. Some of the compute module based and some are Pi Zero based. So this is just one example, but this is the sort of thing we need to adapt to minimize the image, have fewer running services, and none of that desktop stuff that I've been having so much fun with. So I'll go through like how we're going to crush this all down to make it better for smaller devices. So let's have a little think. Where should we start? Let's go over here. So the project that we're working on is Retro Home. This is the Git repository here. I think I've pushed up most of my changes. Oh, maybe I haven't actually. 2 days ago. I've probably got some unpushed changes I probably need to push up, in which case. But let's go over here and start by, I just made some notes, so let's talk about what went wrong. I think that's the first thing. So what went wrong on Friday? So what went wrong on Friday was this. And it isn't actually, I didn't do anything wrong. It was just happenstance. So what happened was we were running the build system and we got to this piece here. And for reasons I can't explain, these 2 steps here didn't actually work. They failed. I think there was a blip in connectivity. And so these 2 bits that install the minimal X server didn't run. And then it got to this step, and this one did run. And this says install suggests. And the idea is that we only want to install the suggested packages for this package. But because none of the X server stuff had run, and this requires X, it basically said, okay, I need X Windows and I need every suggested package for everything that you're about to install, which is why it was literally installing like every package in the Ubuntu archive. So that was what was going on there. I haven't thought about how I'm going to sort of catch that yet, but at some point I'll have to figure out, it's the first time that's happened, but I'll have to figure out like how to catch failures when I care about a failure being caught or something. So that was what went horribly wrong on Friday. But ever since I've built the images several times over the weekend and they've worked fine. Although I've now refactored things and we'll have to tidy that up to make a build today. So we were looking at the DeskPi Pro drivers, the DeskPi Pro being this case here that I use at home and here as like my dev machine for the Raspberry Pi. And let's just take a look at that. So we've now got these files in case DeskPi, root, user local bin. We'll get both of those. I think there's 2 files in there. And we'll also grab both of those as well. So there's 2 parts to this. There's some Python files and there's some systemd units. So let's just move the 2 Python files together. We'll look at the power off one first. So I've added proc title to this, and what that does is it actually sets the name of the process that's running. So instead of saying in like your process management tools Python 3 space name of script, it will now just say DeskPi Pro power off. And it's less important for this one because this is actually a very quick running script. And I've removed all of the try except nonsense that was in here because I was looking at it and I was thinking this doesn't make any sense at all. So it just didn't fit. And every time I've run this script, it's worked correctly. So now we establish the serial connection. If the connection is open, we run all of the things we need to do. And if it's not open, then we simply exit and return code that appropriately. It's non-fatal. It will mean that the daughter board may remain on, but I haven't actually run into that. Hello, King Egypt. Welcome back. Now, the other change I've made is, you may notice here, it's now referencing dev TTY CH340. So why the heck is it doing that? Well, let's just go and open, I think it's going to be in etc udev rules. So what I've done is this. This is a serial interface, effectively a serial converter, in fact, and it was we were referencing it as TTY USB 0. But it occurs to me that if you plug in any other USB serial device to one of these cases, you could never be certain if USB 0 is the serial converter for the MCU on the daughter board or some other random serial device. So we're using udev to actually symlink whatever USB port this gets allocated to a fixed name. So now we can always be certain that when we address TTY CH340, that will always link back to the actual serial converter on the MCU. So that's a change that I've made there. So if we look at the fan control, again, we're using proc title. This makes way more sense for this because this is a long running service. It comes up, it keeps running constantly, checking the temperature of the CPU and adjusting the fan speed accordingly. So this one's quite good because now when you do a PS tree on the things in memory, you will actually see this sitting here running as the DeskPi Pro fan control, which is obviously very clear what it is when you're looking at it in a process view. Oh, that's a good cup of tea this morning, boy. So I needed that. So I made a subtle change here. Just we always return the CPU temperature as an int now rather than a float. It didn't seem to be necessary to return it as a float. And I've added a simple signal handler function here. And what we use that for is for trapping Control C basically. So this did also have a try accept around it, and when I looked at it, I think it was a pretty shonky way of trying to catch the keyboard interrupt. So we're doing it the right way now with a signal handler. And it means we've been able to get rid of the try accept. And what I've done is I've put inside the loop, open the serial connection, get the temperature. If the serial connection is open, do things. Otherwise, we log in air quotes the fact that we couldn't connect to the device. But what this means is that this is in a loop, and we always close the serial connection. So this will open the connection, do what it needs to do, and close the connection. So because it's constantly running, we can have a connection failure once in a while. It doesn't matter, because the next 5 seconds later it will probably get a successful connection and adjust the fan speed. So the other thing I did here was we had this good idea from King Egypt on Friday to invert the way we did the logic for the fan speed. And what I've done now is I've actually put a variable in for the fan speed, so it's a little bit easier to see what's going on. We actually log, and again, I'll explain logging in just a moment. We log the temperature and the fan speed here, and then we build a string, which is the data that we're going to send, the data packet that we're going to send to the serial converter. So that needs to be PWM underscore, and then the fan speed padded to 3 characters. So that's what we're doing here. So if our temperature was 9 degrees, which it never would be, this would get padded to 009, for example. More commonly, our fan temperature of 45 degrees gets padded to 045. And then we send that to the serial interface and we encode it on the way. So that's how we're dealing with that. So this is just a little bit tidier, easier to follow now. Good morning, noob of the Linux, welcome. So those are the improvements I've made here. I'd like to continue to use this in the other scripts that we create TAC of, so that the long-running processes are easily identifiable in the process tree, and also using signal handlers in this way as well, just to sort of make them a little bit more robust. So that's sort of those changes and improvements, and I commented them a little bit as well to explain what they are and what they do. And I think, so we've looked at the UDEV rules, and then I think this required a couple of changes. Let's look at the power off one. Yeah, this one was fine. There was nothing to change here. But this script needed some changes. So it didn't have a typeset, so and it said remain after exit. So the way that the script was originally written, with the try accept and everything, it was said remain after exit, but when you actually tried to use any of the systemd analysis tools, it would always report that this service was still in the initialization phase, that it hadn't actually completed. So you couldn't use systemd analyze, for example, which was a pain. So I've just refactored this ever so slightly, so that it now starts it as a simple service, and it's got an on failure recognition. So if that should crash for any reason, I don't know what would cause it, but let's imagine it can't connect to the serial interface in some way that causes it to backtrace, then it will get restarted by systemd. So that fan controller process should, keep working. And then because we're now using UDEV rules to set that name of the device, we want this unit to run after UDEV has settled. So I've just added that there. So that's what's going on here, and I'm making a lot of use of systemd. We'll be coming back to that again later. So those are the driver improvements, and I'm much happier with how they're looking now. So now we get on to optimizing this stuff. So why are we optimizing for handheld devices? So I want to get this right from the outset so that effectively it's the same project but built in a slightly different way to target handheld devices. I want those images to be smaller, not because they they have less capacity, but it should mean there's fewer running components. So what I'm trying to do here is remove unnecessary services. So I don't want unnecessary stuff running on the device, because that's bad for battery endurance. So we want to keep that as minimal as possible. And I already talked about last week some of the optimizations that I've made there with regards to using things like IWD instead of WPA supplicant, for example. So some of that work has already been done. And then, of course, we won't have all of that desktop stuff, and we won't have a display manager. So we're going to need to deal with that ourselves. And then when you've got a device like this, you don't have a keyboard and mouse. You can't connect a keyboard and mouse. I'm trying to think about this from the perspective that you shouldn't have to SSH into the device or even use that desktop that's embedded in the set-top box versions to correctly control the device. So we need to be mindful of that and do some things. So we're going to take a look at all of that, and I think I've made the appropriate notes in there. So let's just go back to the bootstrapping stage, because this is the first place where some of these optimizations are going to take place. And here are some of the changes here. So this is what's responsible for putting the initial base packages into the what will become our image in order to build the operating system. So what I've done is I've expanded the use of the exclude and include, and I'll explain what's going on here. We were already excluding NetPlan, and we're also excluding the package Ubuntu Minimal, but not the actual packages in Ubuntu Minimal. And now I'm also excluding Ubuntu Advantage Tools. There's a whole bunch of stuff that comes along with that we simply don't need in any version of RetroPie, particularly on the handheld devices. So this helps keep the image smaller, but significantly reduces the number of running services and scheduled services that are going to run on the device. But then the inverse is, there are some things that we want. We do want the Avahi daemon, and that's so even if you've got a handheld one or a set-top one, its network services can be discovered on the network easily. And we specifically want to get this package in early because this is facilitates the file system expansion, and this is a smaller package that can help us do that. The default package actually pulls in QEMU, the whole of the virtualization manager. So we specifically bring this package in to prevent all of QEMU being sucked in later. And then we're going to include Nano because it's the best editor that was ever created. And due to the next change that I've made, Nano wouldn't have been installed otherwise.
Thank you for the follow, Tetsu_study.
Hey Tetsu, thanks very much for the follow. Welcome to the stream. King Egypt, yes, I did fix the problem. It wasn't a bug. I explained it just at the beginning of the stream. So when I'm done, if you just watch like the first couple of minutes, you'll hear the explanation of what went wrong there. I didn't actually have to fix anything. It was just an unfortunate situation. So down here, we're saying to install what's required for the file system expansion, and we're also specifying this package again just to be doubly certain that the other one doesn't get selected in preference and installs QEMU into the image. And then finally, after studying this, I've decided we're always going to install just the dependent packages from the Ubuntu standard package. That gives us a whole bunch of useful utilities that you just want on a system, but then none of the recommended packages, which again is a whole bunch of services and extra stuff that we really don't need on any of these devices. So this now defines our initial base image. This has some advantages that the build system is faster to complete now as well, which is kind of handy. So that's the initial bootstrapping stage. And at that point, we now need to think about how we run this thing without the desktop. So the handheld device, we don't want to ship a desktop on it. There's no point in doing that. But there was one advantage of having all of that desktop stuff, is that we have a display manager. In this case, we're using LightDM, and that actually brings up the X server and enables us to launch a particular X session, which in our case launches Retro Home and gives us that fallback to a sort of miniature desktop environment. And we're going to have none of that facility. So what we now need to figure out how to do, and I say need to, I have figured it out and I'll explain how it works in just a moment, is without LightDM, how do we bring up an X session, but in the way LightDM would have brought up the X session, which means we do want things like dbus to be working. We do want things like the policy kit daemon to be up and running. There's a whole bunch of stuff that we do want bringing up. Not, you know, like a desktop session.
247.
Hello, Black Arrow. Welcome to the stream. Thank you for the follow. So, these have not been trimmed down any. I think this is the same as we left it Friday. This is the same as we left it Friday. And then now we have this, which is where it's different. So we have this conditional, and I'm going to change the logic of these in just a moment, because I don't like how this looks at the moment. It always confuses me, even though I wrote it. We're saying if we have a desktop being installed, then this code here installs the display manager. And this code here configures the display manager. In this case, again, it's LightDM. And then we have, otherwise, you know, if we're not getting the full desktop experience, then do these things. And this is what's required for us to effectively boot to the X server and start the X server and start our Retro Home session. So we'll just take a look at what we're installing here. FBI is an image viewer for the frame buffer, and we'll get to why we're using that in a little bit. Fonts M+, so you'll see that I install this, and it's the font I use in the desktop environment as well. The reason for that is this is the font that's bundled with Ludo and is used in Ludo itself. So I thought for consistency's sake, I would use that font everywhere. And then we want X in it, and X in it provides us the tools that we need in order to bring up an X session. And in order to bring up an X session, we're going to use a systemd unit. So we'll take a look at this, and I have to say, a little bit of Googling is always your friend. So if we look at that systemd unit, here it is here. This is terrific because it doesn't bring up X as the root user, it brings up X as our Ludo user, our regular user, because we did all of that work to make Retro Home work in a regular user context with policy kit to enable us to disable the services that you can manage in the UI. So you can enable and disable SSH, Samba and Bluetooth. But you can do that from a normal user account rather than having to run the whole thing as root. So I wanted to preserve that. So anyway, I found this terrific blog post here that describes how to use systemd to bring up X11 and run it in a user context. So I've left that in the unit file. This is a terrific read. The author has gone to some considerable length to explain exactly what each of these bits do, so that you can take that and reuse it. So I have changed it slightly from the author's original. The changes that I've made are to always restart this, and that's because in Ludo, if you do have a keyboard connected and you press escape, that is the kill Ludo command. Now obviously if you're running this on a device and you press escape, you really don't want to be left with a black screen where you can't do anything, because in the user interface for Ludo there are the options to reboot and shut down the device. So if you do accidentally kill Ludo, it will respawn it, which is good. And I've just put it on VT7, which is the traditional VT that graphical sessions run on Ubuntu. So I saw there was a question here from Noob the Linux. Let me just bring that up. So they ask, why X and not X Wayland? Well, that's a good question. I think the reason is Ludo, which is the graphical front end that I'm using, is work in progress to have that run on Wayland. It's not quite there yet, but that's Wayland itself. So at the moment I need to run it on X, but everything I've done so far is done in such a way that hopefully if I do want to switch to Wayland, it should be fairly trivial to move those components around and bring Wayland in, not just for Ludo but also for the micro desktop. So I've got my mind on it, but at the moment it's not quite there, so I'm not doing it. But it does use Pipewire, and in fact using Pipewire was a massive win, and I spoke about that on Friday. That was a huge step forwards. And Tommy says Wayland overall isn't quite there. It can be if you look at the work that the Sway, there's a window manager for Wayland called Sway. If you look at what that team has done to add additional protocol extensions to Wayland, it can be pretty complete. It's just a lot of those extensions are not used in GNOME, which makes, and KDE has some but not many. So yeah, it can be limited, but it doesn't need to be. Yes, and Nano for the win. Yeah. So the reason I'm manually installing Nano is it is the best text editor, and also Nano is a recommended package in the Ubuntu standard meta package, and we're excluding those recommended packages, so I'm cherry picking to include Nano. Right then, so this is how we're bringing up our X server. So this is the main line here. What we're doing here is using StartX. We're then using our Retro Home session script, and we tell it which VT to run it on, and then we're logging into so /storage is the home directory for the Ludo user, and that's because Ludo, when it's run in this sort of set-top box mode, is hard-coded to use /storage as where its data lives. So we're honouring that. yeah, Zoom, screen sharing. Yeah, I do use Nano, by the way, Esme, and good morning to you. I love Nano. It's great. Right then, so that was the main piece here. So if we just look back here, what else have we got? We then copy that over. So we've got a couple of bits here we'll take a look at. In fact, that piece, I think we can move. I think I've just seen an improved. Yeah, we can do this. So let's have a look here. So we've got this. Oh, I see why it didn't work as well, because I haven't copied the system D unit over. Okay, so we'll just go and look at a couple of scripts. I've just seen a bug before we build it. So we'll just take a look at this. In fact, I've written a little script here. Now, this was fun and games. FBI is an image viewer for the frame buffer. So before X gets brought up, at some point in the boot process, the frame buffer device becomes available and we can display graphics on it. So what we're doing here is, first of all, this is a little workaround for an issue in the build script where the font cache isn't correctly formed all the time. So this is a nasty workaround, but it's serviceable. What we're doing here is we're waiting for the frame buffer device to become available. So we sit here and we say, while it doesn't exist, wait for 100 milliseconds. And then once it's available, we then tell FBI to display an image on the frame buffer. And this is just, at the moment, a blank, sort of a grey abstract image, just to demonstrate that it works. And then I've got this here, which I probably don't need anymore. After we've displayed that image, I was then, because I'm logging all of this, I was then seeing how long it takes for the X process to start up afterwards. And the reason I was doing this is when I started, I was using LightDM, and it turned out that the frame buffer device was available at the exact same time that the graphical target got hit, so I could never do this splash screen thing. So I'll explain about the splash screens. What we're doing here is I want nothing to be displayed on the screen except for the things that I put there. So I don't want a scrolling kernel messages as the system comes up. I want it to display a logo and then display the running application. I don't want, a whole bunch of text and, Linux mumbo jumbo on the screen. So part of this is display something on the frame buffer, and the other part of it was this, which is, if I go to boot CMD line, this is the kernel parameters that we pass, and I've added to those these ones here. And what this does is try to silence those kernel messages. So quiet, you may well be familiar with. Log level is basically telling the kernel, don't tell me about anything. Whole bunch of instructions for systemd and udev to not display anything. When Plymouth detects serial consoles, don't do anything. This technically should never be necessary in Ubuntu, but it's just there for completeness. You may be aware that the Raspberry Pi OS displays little Raspberry Pi logos, and there is a way in regular Linux to turn on Tux logos at the boot prompt, and this disables those. Console blanking, this is to prevent the console from screen blanking, because again, if you've got a handheld device, you don't expect like the screensaver in air quotes to come on and just blank the screen. That would be an unexpected behavior. So again, we're making sure we keep the screen awake and alive at all times. And then the last one, this is a fun one. This is stopping the cursor from appearing on the console device. And again, this is so when you've got a completely blank screen, you still get a flashing cursor in the corner of the screen, and this disables that. So this is just to like silence as much as possible. And then the other little trick that I've done here is I've moved the console onto TTY2. And that's that there are a few things like the real-time clock workaround for the Raspberry Pi, FSCK, the file system expansion. All those things ignore all of these other options to silence them, and that they will log to the console. So I've moved all the console output onto a VT that isn't displayed by default. So we obviously get TTY1. It's now completely blank until the splash screen kicks in here and displays our image. So I can see there's some comments here, so I'm just gonna take a little look here at what we've got. Oh my gosh. Vim, okay, yeah. What have we got here? Hello there. Hello, White Panther, how you doing? Thanks for stopping by. Hello. Good to see you. So I'm just explaining how we're going to optimize this for this OS I'm working on for handheld devices. That's the task today. So Tommy, it looks like Yeah, you've been having a good old chat there about the SXI. Gosh, oh, and Vim. Oh my word. Okay. Right then. It seems to be having a good chat amongst yourselves. That's fine. So this is actually not going to work at the moment, because what I've noticed is there's a critical piece missing from this bit here, which is we need to copy in the system D unit for this. So this is a generic solution. So this is going to be in root user lib system D system, and hopefully retro home splash. There it is. So we're going to need that. Because without this, it's not going to do anything. And then we're going to need to enable that service. And then we'll just go and look at what that actually does. Now, technically, I can do everything that that script does in System D, but it turned out it was very, very difficult to debug why things weren't happening. So I've elected to put it all in a script so I can better monitor what's going on. But if we take a look at this, we'll see it's a fairly straightforward System D unit. So what we're saying here is bring this up as fast as possible. So we put it in the basic target, which is very early in the process. All we've said is make sure the file systems are available, because we need to load the script and load graphics and stuff like that. It's a simple service, so this means just assume that once the script is executed, that was successful, and then we just run that shell script, and then we use systemd to pipe the output from that script into some log files so we can track how it's running and all the rest of it. So that was actually missing, which is why this morning when I tested this and I was thinking, where's my splash screen gone? That would explain why. So that should take care of that issue. And then all of this is the same from last week. And I've just sort of collapsed up the sound stuff a little bit, because in here I actually had a library being installed, which is libcambra pulse, which is only required by the desktop. So I've moved that package out into the desktop stage so it doesn't get pulled in. Then this is all the same, installing debget so we can easily install Ludo. And then what I've done now is I've moved all of the configuration for Ludo into this Ludo stage. So this is the bit that puts the units in place that you will have seen the toggles. We'll have a look at them later, where you can toggle things in Ludo for SSH and Samba.
Thank you for the follow, Maciej Pedzic.
Hello, Maciej. Thanks very much for the follow. Welcome to the stream. These units are interesting. So what they do is they look at the Ludo configuration and see what the state of the toggle is. And if the toggle has been turned off for any of these services, it then stops those services effectively. So you can, have the state persist across boots. All of this is the same. It's just been moved. There's one.
Thank you for the follow, Wolber Amarim 10.
Wolber. Well, what an interesting name. Welcome. Thank you very much for the follow. So one weird little quirk is, because Ludo is intended to sort of run on a LibreElec based OS, it has its own atomic update system for updating the full LibreElec image. And what I'm doing here is deliberately preventing that update mechanism from working so that nobody can use that facility and accidentally download a massive image. I'm going to figure out a more elegant solution for that. At some point I'll submit a patch upstream to the Ludo project, but for the time being we're just making it impossible for those processes to work. All of this is the same and as it was. This is all fine. The micro desktop is unchanged, I think, other than the fact I've similar to Ludo, I've moved all of the desktop configuration into this stage. So this does the install and the configuration now. So that's the only change there. And I think at this point, this is the same as we left it from last week in terms of how the kernel configuration works. That's all the same stuff. This is new. So this is part of the optimization. So I was using, so the reason I found out that those DeskPi systemd units were busted was because I wanted to use systemd analyze and I couldn't because there was this service that was perpetually in a initialization state, which I've since fixed. So by using systemd analyze time and blame and looking at the dependencies for the graphical target, I found out that raspiconfig adds about 1.7 seconds to the boot time, and it's an irrelevant component for what we're making here. So what raspiconfig does is enables you to hold shift whilst a Raspberry Pi is booting to change the CPU governor. This is not something I need or want in Retro Home, so we're going to disable that service and buy back 1.7 seconds.
Thank you for the follow, Krishna Kaiwatya.
Hello Krishna, welcome to the stream. And then similarly, we know we're never going to use TTY1, so we don't want any like login screens or anything like that to flash up on that console, because we want that to be completely blank except for when we choose to display an image. So we're disabling TTY1 entirely to maintain that pristine black, nothing going on screen. So that's what those two changes are for. And I think that's kind of it. That all of this stuff is the same. Oh, what are these? What's this now? That's fine, I think. I was just looking to see if some of these I might want to use. And we're also compositing the image a little bit differently now. We're doing that each build. Oh, and here's another modification. We've customized the message of the day, so we'll have a look at that in a little bit. Made some customizations there. And here's the case support. So none of this has changed other than the fact that I've enabled lurk in the appropriate manner for the DeskPi Pro. Hello Mache, how you doing? Oh, Mache's asking what's going on. Okay. I am making an operating system for the Raspberry Pi based on Ubuntu 22.04, and that operating system is a retro gaming emulation OS. And today I'm optimizing the build of that so it'll be suitable for handheld devices like this one. So this is a handheld device you can put a Raspberry Pi Compute Module 4 in and then, play games on it. I haven't got to the point where I've enabled the device yet, but we need a minimal, version of the OS, and that's what we're working on right now. So let's just go and look at a couple of things that have changed here, because the other thing that's changed is the script that brings up the Retro Home session has been tweaked a little bit. So the first thing it does is it puts a splash screen up. And again, this is so we can try and demonstrate progress in the boot process. This is the Chelsea cucumber. This is a channel meme from another project that I work on. You're going to run out of channel points soon, Takov. That's an expensive one. And then similar to making sure the console never blanks, we also want to make sure that the X server never blanks. Again, we need to be thinking, the devices that we're using are either going to be something like this, you don't want to be waking up the screen, or something like this, connected over HDMI to your TV. You don't just want it to blank, you want to be able to just utilize this system through the user interface of the of Ludo. So we're turning off stuff or setting things up so that you should never have to SSH into your handheld gaming device in order to recover the situation. And then this here just hides the mouse cursor. I talked about that before. This here is that dirty hack to make sure that the font cache is correctly formed. I need to do something about that in the build system itself. Ah, it's that Mac. It's Mac. Hello, Mac. I now understand. Hello, how you doing? And then I recently added this. And that's because what I've discovered is on the Raspberry Pis I've been testing with, the analog audio is set by default to like 52%, and the HDMI audio by default is set to like 75%. So consequently, the volume is quite low. It's difficult to hear, and also there are volume controls within Ludo for controlling the volume of it. So what we're doing is making sure that all of what are called the syncs, the audio devices that output sound, have their volume always set to 100%. And now that means that you can just control the volume using where it's available, things like this, or in the Ludo interface by going to the volume settings and configuring the volume just like you would on a regular console. So what we're doing is always making sure the actual devices are at 100%, and then in software through the Ludo front end you control the actual volume that you want the thing to play at. And then this was a fun one I found. I actually got myself in the position where I turned off full screen mode, and then coming into the session, it was then, tiny in a corner. So what we're doing is when we're coming into the Retro Home session, which is console mode, always make sure it runs full screen. Here's our little workaround for the capture card stuff that I talked about last week, and then actually launch Ludo itself, which is the front end for doing all of this stuff. So those are the changes there. I think that covers like everything. This is all fine now. So something else I think we need to do is I haven't actually copied over this kernel command line parameters for the case that we're working on at the moment. So we'll go to DeskPi. Is it? Yeah. Oh no, that's fine. Command line's fine. This is fine. This is common. This is common. Let's just double check the kernel configuration. Yeah, okay. That's good. Right. So that's fine. That was just something I had in the back of my mind from earlier, because I noticed a mistake that I made in the build script. So this should all be fine. This is all good. And I've explained the volume stuff. So now what we need to do is actually go and make this work. So there's a couple of things that I've discovered over the weekend, which is, first of all, I've been calling this DeskPi Pro. They actually make a DeskPi Pro and a DeskPi Lite. I don't have the Lite, but the drivers are compatible. So I think we can drop the Pro from this and just call it the DeskPi. So we can drop the Pro here. And then I was calling these smaller images Lite, but then that gets confusing when you know that there is a DeskPi Lite. So what I'm thinking is we'll rename the Lite editions to Mini. And if anyone's got any better ideas for distinguishing the two. And then what we're doing here is I'm going to create a new, what I call internally here, a new remix, which is for the DeskPi, but a mini version that doesn't include the desktop, so we can test and make sure that all of these facilities of this optimized image are working on a convenient device before I get into the complexities of actually like enabling one of these, which is going to be some considerable effort, I think. So we now call these DeskPi rather than DeskPi Pro, and we can do this. And these cases are specifically for the Raspberry Pi 4. And I also want to move my logic control over. And then I've got this piece here, remix. So although we're defining a name here, the remix is to actually guide like the correct case configuration. So I want to move to a different technique here. So I've got this idea of, at the moment, I've got skip Ludo equals 0 and skip desktop equals 0. And I set it to 1. And it just seems a bit not easy to read. So I've had this idea where we could set the include desktop true, include Ludo true, and then use a conditional like this where it actually executes that true and false command in order to give us a nice conditional. So I'm going to change over all of this skip Ludo stuff and skip desktop to this kind of thing here. So we'll first of all go and find all of the skip desktop references. And we will change. So that's saying if include desktop. There we go. So I think that just reads a bit better now. Makes it a bit more obvious what's going on there. So I think that should be, I can get rid of all of those references to skip desktop now. Yeah. So let's get rid of that. And all of these. And you can see here, we're setting include desktop to false in these images where we want a trimmed down version. Let's think now. Yeah, that one is what we need to do. So this just occurred to me as a neater way to do that sort of, and I might start using that more widespread because I kind of like the way it reads. Why is that unhappy? What's going on? Oh, there we go. Right, so I don't think there should be any others. We should be all done now. Oh, there's one. Okay, if include desktop, then include the display manager and configure it. Otherwise, don't. There we go. So that should be all done. And then we'll do the same thing with including Ludo. And it may seem odd at the moment that I've even got something that says whether or not Ludo should be included. And the reason for that is I might add support for some discrete emulators at some point to create devices that effectively like boot to basic devices. So you can just like make a Spectrum or a Commodore 64 version that just boots directly into BASIC and of the Spectrum or the Commodore 64. So we will do the same thing with skipping Ludo. Include Ludo. Like so. And there it is, if include Ludo, and that should be the only reference. There it is. What isn't it like about that? Oh, it's fine. I'll deal with that another day. I can't be bothered to make shell check happy on that one. It's not important. Right then, so that should be the logic in place for that. I think I'm going to have to go back to the Ludo stage in order to build this. So by default we say include the desktop, include Ludo, and we're going to try and build this one where we say but actually don't build the desktop and use this case configuration. So I think that covers it all. Yeah, that's because my friend Popey and he's a Spectrum nerd and I'm a Commodore nerd, and we are thinking of reviving a Twitch channel that we used to combat one another. Okay. Sorry, I've not been paying so close attention. Let's have a look at chat here. Yeah, so King Egypt points out the GPI 2 case for the Compute Module 4 is 60 quid, and there's even an options dock. Yeah, it's pretty good stuff. I've got, I think, 3 or 4 handheld devices that use different types of Raspberry Pi, so it'll be fun to like try and get them going. This, I think, is the most compelling one though. I've got the original GPI case, which actually required, I think, the Raspberry Pi 0, but the original 0, which I can't use because it requires ARM v6 and Ubuntu doesn't support that. But then I found an aftermarket service, which is a cartridge mod that you can use the newer Pi Zeros in. So I will be making those at some point as well. And one of the reasons I want to get this going is my daughter's getting into playing computer games, and I want her to enjoy some of the classics before she gets too carried away with all the modern stuff. Right then, so I think that's all in shape, and let's just have a look at the build steps. So we're going to need to put that in to test it works and that, but we don't need to do the bootstrap stage. So let's just run this, step through these stages one at a time and build an image. So we've done the bootstrap stage, and we're now going to say this is the Desk Pi Mini. Oh no, I'm going to have to run it from stage 1. We're going to have to do the bootstrap because it's essentially a new device name. That's the wrong password. That's the wrong password too. Can anyone remember what my password is? There we go. Right then, so that we'll let that bootstrap up. So this is the base image, the base operating system, you know, and I think I've explained before, I've got apt caching service configured here. What's this then? So it's only a gnome, says include pi4 equals true, future proof. You shouldn't need to do that. So the way that the bootloader configuration is put together for these, it should be generic. It should work on a Pi 2, 3, 4, 400 and the 0, 2 and the Compute Module 3 and the Compute Module 4. It should know what to do with it in all of those situations without any specific tuning. Now, some of these cases are absolutely intended for a particular model of Raspberry Pi, and what I may do is go back and tweak those config.txt and just the config.txt for those to really make them quite tight and specific to that particular board. So King Egypt says, my immediate response to me saying C64 was to type, yeah, but Spectrum was better. I guess old habits die hard. Yeah, so there's a channel here on Twitch. It hasn't been streamed to in a long time. It's 8-Bit Versus. There's a YouTube channel where all of the videos are archived. Popey was a Spectrum fan, well, is a Spectrum fan. I'm a Commodore 64 fan. And the whole purpose of 8-Bit Versus is to reignite those playground arguments, fights, if you like, which was better, the Spectrum or the Commodore. So what we do is we each take a game for each platform And as the Commodore owner, I have to play the Spectrum version. And as a Spectrum owner, he has to play the Commodore version. And then we have an argument about which was better. And the viewers got to join in the debate and to conclude who won that debate on that particular day. So that's sort of what 8-Bit Versus was. We did a pilot a couple of years ago, just before the pandemic of that, and then that new season we did it in the off season of the Ubuntu podcast. So we did it from December to like March time, so December 2019 to March 2020, and we haven't done any since, but we have been talking about bringing that back. And how we are going to do it in the future. And so one of the reasons for making these retro emulation console devices is that up here, if I can get it, I do have the let's do it this way. I do have this, which is a Spectrum case, and somewhere there's a Commodore one. And I thought it would be fun to actually, use these devices, have them set up to integrate with our co-op streaming configuration so that we can do this. And all of the old arguments are up here. Yeah. Well, you see, you might say that the Spectrum would win every time, but you'd be wrong. And that's kind of the entire point of 8-Bit Versus. And what's interesting is, in the few games that we did play, there were occasions where, despite the disadvantage that the Spectrum had in terms of graphics and sound, the gameplay for some of the games was better than the games on the Commodore. And that was nothing to do with the hardware, it was just whoever wrote the game on the Spectrum did a better job of actually making a playable game. But the same is true the other way as well. We did play somewhere, they were just significantly better on the Commodore, but it often came down to gameplay rather than superior graphics and sound. But when the gameplay was the same, it's very, very hard to suggest that, all that cyan and yellow is particularly compelling on the Spectrum when faced with the Commodore. But that was the whole point. Was to start those arguments again and see if we could settle any of them. So where are we here? It's installing X related stuff, so that's good. And yeah, so I've checked and double checked all of the X related stuff, and it's really I nearly an Oric 1. I had one of those for a very short period on loan from a friend back in like 1979 or 1980, something like that. The other thing we've done with the X configuration is kept it absolutely minimal. That's all good. This is all doing the right thing. There goes FBI. So this is into the Ludo stage at the moment, so we're quite far along here, and it's just useful for me to see what gets pulled in by various things. What was all of that? Oh, that was all the networking stuff. That makes sense. Okay, so my favourite game on the C64 was Mule. What was Mule? I don't think I know that. My favourite game on the Commodore 64, there were so many. I really like Whizball. Whizball was a great game, but also exploited every single trick of the hardware in the Commodore 64. So it was a borderless game. It was presented in a widescreen aspect. So the top and bottom borders were used for the high score and game status. And then the game actually scrolled into the side borders, so you actually had a really wide play area. And when you look at a lot of those games in that era, they actually put the game window in a really small even smaller, space with like massive logos and massive high score status. So Whizball just feels so expansive by comparison. I absolutely love it. And International Karate Plus, because that was just astonishing for, the time. Really great. So how are we doing here? We're at the point where Deb gets going on. So there it is. So now this will install Ludo momentarily. Deb-get does install a lot of stuff, doesn't it? I might have to double check that we're not over-egging that. I don't think so. Let's just... Oh no, that's all necessary stuff. Okay. So... any minute now. So unattended upgrades. I think I should leave those on. I think that's sensible. You want if you've got a set-top box, you want it to automatically pick up the security patches. I think that's reasonable. Okay, so Deb gets on there now, and now it's using deb-get to install Ludo from its GitHub releases page. That is how we can ensure we always have the latest version of Ludo. So it's rather lovely when you work on different projects and suddenly those projects are, complementary to one another. The desktop integration bits of this borrowed from the work I've done in Ubuntu Mate and the Yaru theme, for example, and there we go. So that's completed those first two stages. So let's go, and we should find that the micro desktop is a no-op. That shouldn't do anything. So we'll just run it on its own to be absolutely certain of that. Whoops. So that should, that just populates the stage and then it didn't do anything. So that's fine. So now we'll move on and we'll run the kernel stage, the config, the clean and the image, because these shouldn't take too long. So whilst that's going, so the wizard says International Karate is great, but I only played it on the Amiga 600. Oh, the Amiga 600. God, those were rare. A much maligned machine, but I quite liked it. I know it was sort of towards the end of the Amiga's glory days, but that was a good bundle, I think. Really, got two Amiga 600s. Wow. What I liked about International Karate Plus is that was one of the few games, because I didn't have an Amiga at that time. I got one a bit later on, only because I was working on a game for the Amiga and happened to, needed it for that. But I was never what I would call myself an Amiga owner. But the Commodore 64 version of International Karate Plus was one of those games where I really didn't feel that I was losing any ground to the Amiga version. It's definitely true that the graphics on the Amiga version are better because it's just got more, colours and pixels to play with. But it was so close. It's brilliant. So I absolutely love IK Plus. It was a great game. So that will take a moment to bring the kernel on. So let me go and take a look at this here. So we're going to, at some point, start enabling a bunch of retro flag cases. You have seen I've had that out on the desk here. So we have one of those. I have one of these as well. And one of these, and you may be wondering, this one's interesting because it's actually got a built-in screen, so you can understand why that sort of needs special enablement, and the same is true of this as well, of course. But these cases, you think, well, it's just a Raspberry Pi case. I will get it. And yeah, it is a case for a Raspberry Pi, and in fact I have a Raspberry Pi 4 inside this case here. These are the micro HDMIs. So why do you need a special, build? And that's because it has a reset button here and a power switch. And these are connected to the GPIO headers. And the idea is that you can power the device on by turning it on like that. But then when you switch it off, it shouldn't just kill the power. It should actually use the driver that's monitoring the GPIO headers to intercept, do a graceful shutdown of the operating system via the driver that we're going to write, so that we get a graceful shutdown rather than just an abrupt cut the power. So that's why these cases need drivers. That's really what it comes down to. So there are several examples. This is another one, but as I understand it, this has got, I think, a Pi 3 in it. It's a different model, but again, it's got these reset and power switches, which I think work in the same way. So as we write these drivers, hopefully some of them will have like a common driver underneath. So King Egypt says, I seem to remember that you didn't like that case for some reason. It's not these ones. I think, I'm not sure. Is it this one? Yeah, it's this one. I still need to get to the bottom of it. And we will do when we come to enable. It's this case here. This case here has a slot. I don't think the camera's going to pick this up. I can't get the light to shine. But that's an SSD drive bay. Oops, my chair's just collapsed on me. Which I don't have. Oops. Don't have the SSD caddies to hand. I'll have to find those. But anyway, the issue that I've found is you have to sort of enable some additional device tree overlays in order for these power and reset switches to work. And when you do that, I seem to remember they conflict with the drive overlay for the SATA drive. So don't quote me on this, but I think what I remember is you can either have the power buttons work or the SATA drive work, but not both at the same time. Now, I could be wrong, and we'll cover this again when I come to enable this case. But that's what I think I remember from the last time around. But I'm not 100% certain. We'll see how we go. Oh, and the other thing I'm using today is I've got trying out a new card. We were talking about high-speed cards, so I've been using. This is tiny. This is the SanDisk Extreme. I've got 64 gig and 128 gig. These are the ones that I've been recommending. And this is the Extreme Pro. And they're a little bit more expensive. And these numbers here say that it's a little bit faster. And what I can exclusively reveal is on a Raspberry Pi, this additional performance you'll never see. So you can stick with these ones and save a bit of money. Most of the advantage of these is for pro photography. They're waterproof and weatherproof and various other things. So you're paying a premium for probably features you won't use on a Raspberry Pi. And in terms of using it as a disk for an operating system, even on the PC, I've seen no additional performance over and above what these slightly cheaper ones offer. Blast proof. Yes, it does list a whole bunch of things. It's all of the rate. It's like frost proof and hot weather proof and various other things. So yeah, and slightly faster. I think you probably see it on like high-end digital cameras that have got the appropriate interfaces for these, but on a Raspberry Pi, no. They're only slightly faster, but you just don't see it. Yeah, so hopefully I've explained what I was unsure about that on that case. So let's see how our build's coming along. There we go. We have an image. Retro Home Desk. Okay, so I'm going to need to figure out how to name these things appropriately. That's a minor detail. We'll deal with that. So let's use the card reader here. Let's put one of these new cards in here, and we'll demonstrate how fast it goes. So we won't use the Raspberry Pi imager today. So let's that's the wrong screen entirely. Let's bring up the file manager, and so in our builds directory we should now have this. This is the image we've just made. So this is 1 gigabyte smaller than the regular image. It's probably actually smaller than that even, but I round up the image sizes. So let's open that with the image writer and drop this on our 64 gig drive, start restoring that, and we should see here, we can see the speed. Now this advertises 90 megabytes a second, and you'll see here it will get to about 85 and that's about as fast as the other one gets to. So you know, on this machine, which is current, it's connected to a USB 3.2 C port. You know, one thing I have learned, you may remember, I thought I'd got a dodgy batch of these cards. So these are Kingston, and I ran into a problem. It took me ages to debug. I thought I'd broken my build script because I kept putting Raspberry Pi images on these, and then the damn thing wouldn't boot. And then I figured out it was only with these cards. Well, it turns out it's nothing wrong with these cards at all. Sort of. They don't work when I use this card writer. So I have ordered a professional grade card writer, and I'm going to see if that solves the problem with these cards, because I can use these cards at home with my drive bay based card writer and they all work fine. And I can't be doing with having unreliable equipment, me burning 3 hours investigating a problem that I don't have. So I've invested in a decent card writer. So let's we've got our image written, so actually we can take a look here. So if we mount that, what we can actually see is that it's a 3.7 gigabyte partition, but we're only using 2.3 gigabytes. So that's the size of the OS, is 2.3 gigabytes. Hey WC Dozer, thanks very much for stopping by and welcome to the stream. So let's see if that thing boots. That would be rather lovely. So we'll take that out of there. Yeah, that's why I got them. So it's only a GNOME says that those Kingston Canvas cards that I just got up on the camera were the fastest around, and they're comparably quick to these SanDisk Extremes, and a bit cheaper too. Right then, I have put that in the Raspberry Pi, so let's see if it works. So I've just turned the Pi on. The first thing we're hoping to see is that, which is the bootloader. So at least it's found the bootloader stuff, so I've not broken any of that. But now what we're looking to see is, well, is this going to come up? Because this is now our optimized image, and there is no display manager, there's no desktop, so it's relying on all of that stuff I was demonstrating earlier, the systemd unit to bring up X. So this is the first bit. This is our splash screen, so that's working. And you will be seeing like no signal and what have you, because my capture card is going to get thrown around as the resolution changes. I don't think you'll see that on an actual screen. And then at this point, now the Retro Home session is loading. So this is bringing up Retro Home itself. And there it is. There is in fact running. So this is terrific. In fact, what we'll do is go and wire Fireball is on fire good. So what we'll do is we'll drop over here and we'll let's do net discover, because I can't remember what the IP is, the Raspberry Pi is. There it is, 3.18. So we'll log in as the Ludo user into the Raspberry Pi. I think we're going to have to trash the keys, aren't we? Yeah. Because this is a fresh device and the keys have been newly generated. So we'll log back into the Pi. There we go. So here we go. So I can see there are some things that have not worked. For example, I can see that my modifications to message of the day haven't been applied. So we'll have to investigate why that's not working. Yep, that hasn't worked at all. None of my stuff's there, so we'll have to investigate that. But if we do a process tree, we can see a few things. So let's see if we can spot it. This is all looking pretty good. So what I'm looking, excellent. Okay, so we've got this trigger happy service running here, and that should mean that hot plugging still works. So let's give that a try. Let's just cat the bootloader configuration, and that's not correct. Okay, so my build system is a bit broken here, because this is missing the configuration for because I changed the name of the thing, and I spot my mistake. Let's go here. I see what I've done, what I haven't done. I need to not sudo. We need to move case Desk Pi Pro to case Desk Pi, because we changed the name of the case. And Diego says that on fire is great. I think it can be used both ways. So there we go. So that's why it hasn't pulled in any of my configuration changes. And if we look at case Desk Pi, what will it be missing? All of the things. So let's go and get that right. So let's go back to this build script. We don't need to do the kernels. Oh, yes, we do. Do we need to do the kernel stuff? Can I just, in interests of time, let's grab the one bit from the kernel stage that we need, which will be this here. Whoop. What we'll do is, so we don't have to install all the kernel stuff again, we will just do that and drop that into the config stage temporarily. That will save us many minutes. We'll just drop that in there. So now we can just rerun the configuration and clean up an image stages, which shouldn't take very long. Desk Pi light. Hang on a minute, what did I run it last time then? Oh, it's mini. There we go. Right, there we go. So let's do that. This will only take, and there we go. We can see these things being copied over now. Look, that's good. Oh wow, that didn't take long at all, did it? Let's just have a look and see. Did we see? Oh, here we go. No such file or directory. Oh, okay. Well, that's why that didn't work. I guess whilst we're here, we could go and try and figure out why that's not working either. Might as well get all of the customizations going. Where was that? It'll be up here somewhere. Here. So, CP. Well, there they are. So maybe if I was to... Why is that not changing the permissions even? That's odd. So we could make this -retro home like so. Yeah, okay. Why doesn't that work though? Could I do that? I think I could. Okay, well let's just run that configuration again. See what we get this time. Okay, this is creating the user account, adding it to groups. No such file or directory. Okay, well, I'll overlook that for the time being and I'll figure out why. It doesn't exist. So what would be installing? Update mod-d. I'll have to investigate. Maybe in my minification I've removed whatever sets that up. So we'll just overlook that for the moment. We've got our image, so let's grab another card and write out a new version of the operating system. And then we'll see if that works. And this time we'll use the Raspberry Pi imager to do it. So let's drag you onto the right screen. Hello. Raspberry Pi desk. Hang on a minute. Oh yeah, it doesn't retain the name, does it? Okay, I'm going to have to figure this out. I'm going to have to improve this way it picks up names. So let's write to there and off we go. Yes, do this thing. Right. So what I'm thinking is that build script needs to change so it can support different case names, but different case names that share a common set of configuration and preserving the full case name. So that's just an improvement in the naming conventions that I use. So I'll have a little think about that. We'll yeah, because what the problem here is that we're making a light version and that, or the mini version, and mini is missing from the image name. We need to make sure that that gets preserved. We could do symlinking the configuration. That's not a bad idea. And then it would preserve the name. So maybe we could do that. That would be quite good, because then it would also be clear in the Git tree that this case is actually the same as another one. So maybe we'll do that. Maybe we'll do that. and that would enable me to have a thing called Desk Pi Mini. That, yeah, okay, that would work. That would work. Maybe we'll do that. Oh, we could test that in just a little bit. We'll just see that this is all going to work correctly. We'll just turn off the Pi forcibly. So that's gone off. Check its card. Right, we're done here. Right then, power you on. Let's see what happens. So what I'm hoping is we'll have the case modifications this time. And that's because well, we were missing the fan controller, the power down capability, and also importantly none of that would have worked because we didn't have the appropriate bootloader configuration to customize the device tree overlays that enable the front USB ports and the serial converter for the MCU. So yeah, it's pretty ropey. It would have been pretty miserable. So let's see what we get now. And what I want to test is that I should be able to plug a controller in and it should still hot plug detect controllers going in, because again, we're bringing up our session here without all of the luxury of a display manager controlling all of our environment for us. So we'll just try that first. This will tell us whether some of those case mods are working. So if we plug that in, yes, it tells me that the joystick has been plugged in. So hot plugging continues to work, which is excellent. So let's jump over here and log back into the Pi, and we need to do the keys again. So okay, so now if we look at the process tree, hopefully we'll see some other things in here. Okay, that's all good. So I'm not seeing, let's do system couple status, no, it's desk. This is where now I'm going to remember that these are all named wrong. Desk Pi Pro fan control. Loaded, enable, inactive, dead. Okay, so for whatever reason that hasn't come up. I wonder why. Is it not enabled? Disabled. Okay, so I have a bug in my thing which is not enabling the service, so we'll need to go and modify the build script. So if we do enable the fan control, and yeah, having a little think here, Luke. So we'll enable it, and now we'll start it. And now if we look at the process tree, failed. Okay, well that's worrying. That's definitely working. So let's cat the bootloader firmware. Well, this has got the right stuff in it now, so that's good. And I know that that must be correct because otherwise the joystick being plugged in the front wouldn't have worked either. So I wonder why that didn't work. I bet it's because if I run, let's do this, let's do user local bin, Desk Pi Pro fan control. There we go. So we've got something because we haven't called the thing the right name here, so it didn't. Yeah, so here we go. By changing things, I've introduced bugs. So let's just go and look at the configure step here. Down the bottom here is where it does the case configurations. and we're looking for this. There we go. That is why none of that's working, because these steps didn't run. So, and that's why that service was not started either. So that fixes this renaming of the device here. So we could run these things by hand. And let's try and do that with the correct permissions. Oh, update first, that would be good, wouldn't it? So we'll install those by hand, and that should all be working. Can you add services starts now? Yeah. Ah, yes. That's a good tip. So if you add -- now after enable on your system cuddle line, it will start the service as well as turning it on. Yes, that's a good reminder. Yeah, service. Yeah, and King Egypt's pointed out that the services are still pro, so they'll need renaming. So let's just install those bits. Whoa! Whoa! No, we don't want all of that. So there we go. So I think we're going to need to go and change this, because if we're installing here without a desktop environment, it's then installing those packages is then going to install an ungodly amount of software. So we probably want to bring this to these as well. Otherwise we're going to get, because I think Python these days, it's got Sphinx as a requirement if you install the recommended packages, which requires lots of graphics libraries and bits of X and all sorts. So we'll just make sure these are minimized installations. There we go. Save that. Go back over here. So we've installed the bits. So now I should be able to run fan control. And there it is. And you can actually see that it's reading the temperature and the fan speed. There we go. So that's what it does now. It gives you a little indication of what the heck's going on. But if we let's think now, we also had this one, so we don't want, we start power off. In fact, let's do King Egypt's tip. Let's do enable now. There we go. So if I power off the Pi, I'm now watching the status light on the front of the Raspberry Pi. I'm out of focus, aren't I? Hello, what's going on here, camera? Find my face. Hello, I'm here. Stop focusing on my friend behind me. Right, so what I can report here is this is working. So I said power off to the Pi. That obviously powered down the operating system, but it did send the command to the MCU that then shut off the daughter board and took all power out of the Pi. So that's working a treat. So I think we've identified a couple of little bugs in the build system there. So we'll avoid disaster in the future with that. So if we just hop on over to, but the most important thing is that this is working. Let's power on the Pi again. Bring that up and back to the capture device. So I'll explain what I'm going to try and do in the future with this. When the blank grey wallpaper appears, this is just for test purposes, to demonstrate that I can display graphics on the frame buffer, and it should appear in a moment. As you can see, it takes a while. It takes about 4 seconds for the kernel to initialize. There we go. So this here is just a single image. What I'm thinking is we can simulate a loading screen. We could create a graphic. I'm thinking black screen, RetroPie logo, dots. And we create a graphic with the different dots in different positions to represent progress. And we can use FBI to, instead of just display a single image, loop through that sequence of images to give the impression that there's like a loading animation. So a poor man's Plymouth, effectively, to give you some feedback that the device is coming on. Because it does seem to take, I think we can shave 1 second off the boot time by telling the Raspberry Pi bootloader to not delay itself. I think there's a 1 second delay by default, so we'll get rid of that. But like I say, the Pi kernel takes about 3.5 seconds to come up. In fact, instead of guessing, let's actually go and do it. So if we log back into our Raspberry Pi here, we can do systemd analyze time. And here we go. So the kernel took 3.8 seconds to come up. The whole device took, well, this is a lot slower than the one at home. The whole device took 18 seconds to come up, and the graphical target was reached in 17 seconds. So that's curious, because yesterday I got the thing in under 10 seconds. So let's do system lame and see what all of the services are that are coming up here. The wizard asks, why is there a default delay on the Raspberry Pi bootloader? My understanding is it's a safeguard to ensure that any SD cards you've got in the device are actually up and getting power. I've not found any circumstances where turning that delay off has had any adverse effects, but I haven't done it yet, but we can do. So this is all the services. Oh, it was the waiting for the network connection. So that's reasonable due to the very unusual way I'm having to connect the thing here. And this one happens in parallel, so that's fine. And here's our service here, which actually brings up the X session. So if we do system couple list, what is it now? Dependencies, graphical.target. Have I got, oops, didn't mean to do that. Have I got that command right? Well, let's just cut that. What typo did I just make? Oh, no things. Okay. So curiously, it seems to think that there's an issue with that service of mine, so we might have to go and look into that. But we can see a dependency tree here for getting to the graphical target. The graphical target being the place at which we launched the X session. We don't need to worry about this display manager service because we don't have one of those anymore. And as you can see, it goes unrun. And all of this is the stuff that we actually need. There's our fan control service there. That's all fine. But it's curious that it's unhappy about this one. So let's just try and find out. Why? Yeah. Goodness me, I can't type for topping. There we go. State timed out. I wonder if that's because... Let's try and prove that I know why this is. I think it's because I've got that long-running tail on this script. So let's... What's it called? Splash. Let's just do an exit here. Clean exit. avoiding this bit. I think it called system D timed it out because this takes many seconds to wait, and I don't need that there anymore. So let's assume that's got it, and let's reboot the Pi. And if that's the case, we'll go and modify that script because I don't need that checking for the xinit being up anymore. Not even so. So the wizard says, I'm not seeing this coming up at the moment. So not even my desktop boots in under 10 seconds. Stuck here in system D for 19 seconds. Extra disk controller, yeah. So that system D udev settle I'm now using, as I explained earlier. Hang on, why have I got no functioning Raspberry Pi? It isn't rebooting, is it? Something's not right. Oh, there it is. It's actually coming up now. Okay. That took a while to shut down. We'll have to investigate that. So my plan for further enhancing this is we'll add that faux progress animation in the boot process. So instead of what I hope will be this screen about to pop up, it's not appearing at all now, is it? Okay. That's curious. Oh, I wonder if I need to... Oh, okay, so I completely sidestepped the whole thing this time. What's going on? So let's log back in. And... there we go, that did work. So yeah, I was right that we need to remove that bit of code. So we'll do that because it's redundant stuff now. We'll just go and clean that up quickly. So we don't need to do this anymore. There we go. Right then. I just want to test something because let's think. Right, that's rebooting. Let's bring up the capture device so we can see what Pi's doing. So that's it off at the moment, so we should see the bootloader kick in. There it is. I just want to make sure that my that script is still displaying an image on the frame buffer. And although it's a minor point, the fact that this screen is black at all other times is a huge win. That was too much effort to actually achieve such a simple outcome. I'm not seeing my image being displayed anymore. Why on earth not? What's going on? Why? Why would that stop it from flipping working? Now I'm confused because I've removed the code after it, and I'm going to have to investigate. That's curious. I mean, it's not critical, but it's curious. Okay, so this isn't. Oh, interesting. Oh, okay.
Thank you for the follow, Daniel.
Now I know why that might not be working.
12,321,123.
Wow. Hello, Daniel. Welcome to the stream. Thanks very much for the follow. I understand why this isn't working. So also, I'm missing some of these font config tools, which we need. So let's just go to my own machine and do FC cache. That's in font config. Okay, apt show font config. So we're going to need to make sure this gets installed in our okay. let's go and test this, because again we're going to need to make sure that this is apt-get install font config. This has the potential of installing a load of stuff, which we don't want it to do necessarily. Okay. Oh. This also explains why, there we go, that's working now. This explains why the font cache was broken and I had those funny workarounds in there. Okay, so we need to make sure that font config gets installed along with the minimal desktop session. So that would be brain up here. In here, we need to make sure that font config, oops, is what we need. There. Okay, so that was another missing component, so that's another bug fixed, which is good. So if I now go and reboot this again, I think that splash screen should appear now. So the reason that this, yeah, I sometimes do need a brain upgrade. It's just trying to like remember, because I've removed a bunch of stuff. It's like unexpected behavior when things have stopped working. Why has it stopped working? Now, the reason this FBI has stopped working is it has the ability to print text. But if it can't reference the font cache, that doesn't work and the whole application fails. So I think this should display that image now. I really hope it does. It's not going to, is it? Oh gosh, that's even worse. I've now got the console login. So that half worked. I can tell because it's on TTY3, FBI tried to do something and failed. That's a pain. So how can we investigate what's going on here? We will do these things. We will drop into here. We will log back into this and we will disable that auto login. In fact, no, we won't disable it. We'll just stop it for a moment. Is that actually going to do anything? Why is that not stopping? Okay. Let's disable it then. We'll reboot. And this will get us to just the VTs, and then we can log in and actually try and figure out why FBI is not functioning. Development, it's a graph, and most of it's figuring out which steps to avoid. Yeah, it's just a bit frustrating, because what I was doing is I was adapting a big image at home, and then I copied over, changed some of the configuration in the build script in order to try and recreate what I thought I'd come at as the solution. But in actual fact, I'm going to need an actual Raspberry Pi keyboard, I've just realised. So, I think if I do this, there we go. No, that's not what we want. It's this. So it's still waiting for the frame buffer device to come up. Oh, and it's reasonable that it would be permission denied because I'm just a user. So, oh no, that's fine. So let's do that. There we go. So that's working. And I should be on, if I go to TTY2, TTY3 is where the image is displayed, and TTY4 was where I was logged in. That's my blank screen. So let's go back here. Sudo rm bar log retro home splash.log and sudo reboot. Oops, that's helps if we could spell that. Right then, let's see if that image shouldn't appear, because it should still be busted, I imagine, but I should now get a log file that tells me maybe why it's not working. But, how curious. Nope. Oh, there we go. So that's when I think it should be displaying the image, but it's, yeah, at that point there it should be displaying the image, but it's not. And TTY4, TTY3, yeah, so now all the TTYs are available and I could log in. Why has this stopped working, I wonder? It looks like it should be working and it's not. Okay. Well, that's disappointing AF. We'll have to figure that one out. Not the end of the world, it's just weird. Nope. That appears to be doing the right thing. It's found the font cache is built. I mean, I could FC. Let's properly rebuild it. There we go. We'll just try one last time. So what I did learn is that FBI can display text on the overlays on the images that it puts on the frame buffer, and it tries to use a monospace font by default, and if the font cache isn't correctly built, it will just fail outright, which is why I've been trying to make sure that the font cache is clean before FBI is executed. But it doesn't look like that this is the problem anymore, so it's something else. Why? Could it be that that image is missing something? So let's try and log in. So I'm waiting for the other TTYs to come up. There it is. In fact, at this point I can log in a more convenient way. Yeah, they're both there. They're both readable. So I don't know why that's not working. Unless it's because the VT that it wants to display on isn't available. It could be that. It could be that. Maybe I'm bringing it up. Okay. It could be that. So what I'm thinking now is, oops, that the systemd unit that brings this thing up, user, this systemd unit here, I've said bring it up as fast as possible, but I think we also need to add an after in here which is for the Getty services or something to run. This could delay things unnecessarily. Okay, I'm going to have to give that one some thought. See you, it's only a GNOME. Have a good one. Yeah, I'm going to have to give that some thought. So, next steps will be getting that to work and then animating it, and also adding Plymouth to the desktop version to create a similar sort of, you know, progress feedback thing for the set-top cases. So, and then I also need to improve the naming conventions down here so that we get the correct image name out of the build process and what have you. So that's something for me to have a think about. So yeah, I think those next steps, clean up all of that, and then I can hook up with Takeoff and we can start thinking about some of the simpler set-top cases to get working, because they only have 2 buttons, so not dissimilar from this Desk Pi in terms of like basic operation. I think they may have fans in them, but I don't know if they're controllable. We'll figure that out. Okay, I see. Somebody who raided me the other day is streaming, so I think we should go and return the favour. That would be good, wouldn't it? So we are going to go raiding. Thank you all very much for coming. I'm not streaming on Wednesday this week because it's birthday party time for my daughter, which will be good. So I will be back on Friday, I think. Almost certainly. So I'm not sure if we'll be bringing this up again or working on one of the other projects on Friday, but possibly this, because it's getting dangerously close to actually getting a whole bunch of cases enabled. But for now, thank you all very much for coming. Thank you for the new follows and what have you. I'll see you Friday for something, probably more Raspberry Pi stuff though. Thanks very much.
Thank you for the follow, Tux Time.
Thanks, Tux Time. We're just heading off. Here we go. We're going over to Star Ansible. Here we go. Bye for now.